We're going to take a look at our one of our last things. We've got about 3 things left to cover in the algebra. One of them is rational expressions, so we're going to take a look at rational expressions, and we're going to look to do 2 things with rational expressions. Just means sort of expressions that have a numerator and denominator. They're fractions. Okay, so we're going to take a look at simplifying and solving. So we're going to start with simplifying, which is kind of the easier thing to do. So although here's our question. So we need to simplify this rational function, and you'll notice that we've got a quadratic on the top and a denominator on the bottom of x plus 3. And really it's not that hard if you know how to factor. So what we'll do is the mechanism for this is we're going to factor the top. Factor the top. X plus 5x plus 6 will factor to this. X plus 3 times x plus 2 all over x plus 3. So we've got this sort of situation here, a times b over a. Now we know that in a simple expression, a times b over a means that we can cancel those a's out. So guess what? We can cancel out these x plus 3's and we're left with just equals x plus 2. So that function, although it looks quite scary initially, if you recognize for what it is actually quite simple to simplify. It just requires some factoring skills. The next one, now this one, same sort of idea. It's got a quadratic on the top, but I can't use double brackets to factor that because it doesn't work like that. But I have a common factor. Remember, when you're factoring, you always look to see if you can common factor. I've got a common factor of x, so I can take out an x, and I'm going to be left with x plus 5, x plus 5. You see, if you do these right, you end up, something will always end up canceling away. So again, I've got this a times b over b thing. Well, the b's cancel. So these things cancel, and this just simplifies to x. Pretty simple stuff if you recognize what they are and how they work. So we'll try this one. Again, I've got a quadratic on the top and a thing on the bottom, and all I'm asking to do is simplify. So I'm going to factor x, now 12 and 7. 4 and 3. 4 times 3, and that's 7, yep, plus 4, x plus 3, all over x plus 3. Boom, cancel, x plus 4. So those are just rational expressions. They don't take too much work. You just have to recognize them for what they are, and there's lots of these examples in the New Lake book, and I want you to go over to page 42 and 43 and you can do some of those. Now, solving rational expressions, a little bit more to these. So again, we've got fraction on one side and we've got a fraction on the other side, and there's an equals in between. So this is an equation, we have to solve it, and then the direction is solve. Now I might teach this quite differently if I had a little more time, but I'm going to show you a sort of a shortcut for doing this, and the shortcut is to do what we call cross multiply with these kinds of examples. Easiest thing to do, take this term on the top here and diagonally cross multiply it with the 3. So I'm going to end up getting 3 times 2x plus 5. You've got to put your equal sign in, right? To put your equal sign in, and then you cross multiply. No, let's get rid of all that. So what we're doing is we're cross multiplying this with the 3, putting our equal sign in, and then we cross multiply the other diagonal pair. So that's going to be negative 1 times x minus 1. I want to put that back in there. I don't know why. And so then we got that. So what we do is we expand it out, so we're going to get 6x plus 15 is equal to the negative 1 times the x is just negative x, and the negative 1 times the negative 1 is just positive 1. Now, this is just a linear equation. I have to solve for x, so I've got to get all the x's on one side. I'm going to have 7x plus 15 is equal to, and that's gone away now, so that's just 1. And then I'm going to minus the 15 to the other side, so I can get the 7x by itself. And that's going to give me, what's that going to give me? It's going to give me 7x is equal to negative 14, right? And then the last thing is just to divide by the 7, so I can get the 7's to go away, and I'm left with x is equal to negative 2. Solution, solved for x. So cross multiplying. Take the diagonals, multiply them together, hit the equal sign, then cross multiply the other diagonal, and then solve it as just a straightforward, simple linear equation. All right, let's take a look at this one. Now this one, do I have another one? Or is that just the only two that I have? I think that's the only two I have. Okay, so this one's quite hard initially, because I've got this to deal with this thing, this whole number 6. But initially, you can see why we learn to simplify first, because this thing on the left-hand side, all of this can be simplified, right? So I can factor the x squared plus the 4x plus 3. So let's just do that first. So that's going to be x plus 3, x plus 1, right? And then I can factor the bottom part, because that's a quadratic as well. And what is that going to factor down into? That's going to be x minus 2. Can only be minus 2 in 1 or 2 in minus 2. Or 1 and minus 2. So that's the same. 2 and negative 1. Those are the only options. So I need to get the middle term of negative 1. So that's going to be what's going to work. So minus 2 plus 1. Check your innies and your outies if you're not sure, right? Just check your innies and your outies. They should generate that negative 1 in the middle. Okay, so we got this. Now guess what? You see anything? Oh, look at that. That cancels. So then this whole big ugly thing here just ends up being x plus 3 over x minus 2 equals, we can't forget this, the 6. But instead of writing 6, a whole number 6, I'm just going to put it as 6 over 1. Same thing. Now, guess what I can do at this point? This is not the only way you can do this, but I can cross multiply. So I can go this diagonal here, 1 times x plus 3, which is just x plus 3. Put the equal sign in, and then I've got this diagonal, which is 6 times x minus 2. So I've got x plus 3 is equal to 6x minus 12. Now again, I want my x squared, or my x to be positive. I want it to be positive. So I'm not going to probably move it. I'm not going to move it over to the left. I'm going to move this x over here, over to the other side. So I'm going to get 3 equals 6x minus the 8 minus x is 5x minus the 12, right? So I just moved that over, so I got all the variables on one side, but I kept this positive because it's just easier. It's not absolutely necessary, but it's just easier. So then I'm going to go plus 12 over to the other side because I want to get the 5x by itself. This is going to be 15 equals 5x. And then what's the final answer going to be? Divide by 5, divide by 5, x is 3. You got to be a little bit flexible with your brain. Sometimes you have to work on the other side of the equal sign. But that's it. That's the solution. Now that could very well be an excellence question. I'm not sure, but it is definitely a challenging question, and you're going to have to seek those out in your New Lake book and try to find those are on your New Lake book in those pages, and you can